One. Today we're trying to finish up the year with section 7.6. So what this is multiplying and dividing complex numbers in polar form. We've talked about imaginary numbers in rectangular form. We've talked about imaginary numbers in polar form. We've talked about converting them back and forth. We've talked about multiplying and dividing rectangular numbers. And now we're going to talk about multiplying and dividing in polar form. It seems really complicated, but actually the idea here is some things are actually easier to do in polar form. Again, that's kind of why a lot of people like polar coordinates in polar form, is certain things just end up being easier. When you multiply if you multiply complex numbers in rectangular form, for example, we're dealing with 2 plus 3i times 5 minus 3i, something like that. Or we do the same thing, we divide, right? We do 2 plus 3i divided by 5 minus 3i. So when you multiply and divide in rectangular form, not that it's a difficult, especially multiplication, but division can be a multi-step approach. So the idea here is this is actually going to end up being easier. I want to show you where it comes from, though. So basically, here's the concept. So we have one imaginary number. It's got an r, it's got a theta, right? So we'll call it r1 and theta1. And then we have a second number over here, z2, with a different r and a different theta, right? We'll call it r2 and r theta. So the idea here is we're going to multiply those two numbers together. So we end up with, here's our first z and there's our second z. We're going to multiply those together. So when we do that, well, commutative property, basically we'll make it a little easier. We'll bring those r's together. We're just going to multiply those two r's together. Well, but then we still end up with this cosine of theta 1 plus I sine of theta 1 times, and then we have that cosine of theta 2 plus I sine of theta 2. Well, we're going to end up having to FOIL that out. Okay, so when we FOIL that out, we go cosine of the first theta times cosine of the second theta. So we got exactly that, cosine of theta 1 times cosine of theta 2. Okay, and then we go outside, so we got an I. We've got cosine of theta 1 times sine of theta 2 plus, and then we got this second one here. We got an I. We got I sine of theta 1 times cosine of theta 2 when we do the insides. And now we got to do the last. So we're going to have I times I is I squared, but we know I squared is -1, so that's just going to turn to minus. And then we have sine theta 1, sine theta 2. Okay? And then, so what we're going to end up with here, well, we can combine like terms. Well, basically, we have two real parts. So let's bring these two real parts together here. We end up with cosine theta 1 times cosine theta 2 minus sine theta 1 sine theta 2. These two are my imaginary portions right here. So we're actually going to kind of factor out that I out of these two here. So we end up with I of cosine of theta 1 sine theta 2 plus, and then we have the second one, sine theta 1 cosine theta 2. Okay, and it looks really complicated. Well, here's basically what we're going to end up doing though. So if you look back in chapter 5, I took a picture of it here, and basically I'll make this a little smaller so we can compare. Oh, come on, computer, you can do it. You can make it smaller. I know you can. Oh, maybe not. So here, I'll just move this up so we can, there we go. So there's this rule in chapter 5. It's called the sum identity of cosine. And basically what it says, if you have cosine of an angle, cosine of a different angle, which is exactly what we have here, cosine times the first theta, cosine second theta, minus sine of theta 1, sine of theta 2, which is exactly the same thing here, that's the same thing as just cosine of the two angles added together. So basically we can just use that property with an identity and change this whole thing into nothing more than cosine of the theta 1 plus the theta 2. So that whole thing just became that. Plus I, and we're going to do the same thing with that second part. In that second part, there's a different rule. It basically looks like this, and I'll try to get these together. So it's kind of backwards here, but that's all right, community property. So what we have here is cosine of theta 1 times sine of theta 2. We have cosine of an angle, sine of an angle, right? Plus, and then cosine of an angle, sine of an angle, cosine of the angle, sine of the angle. So we basically have that exact same thing here. So we can turn that whole thing into just, and basically what we can do is we can now say this whole thing up here just becomes sine of theta 1 plus theta 2. And it simplifies all the way down to this. Now, what that means here is very simply we have a rule that says if I want to multiply two complex polar numbers, all I have to do is multiply the radiuses and add the angles. That's legit all you have to do. And there's a proof that likewise goes with division, where you will find if I want to divide two polar numbers in complex numbers in polar form, all you have to end up doing is dividing the radiuses and subtracting the angles. You know, I can show you the proof of that one, but you'll probably just want to take my word for it. So here's basically all it works out to. If I have to multiply 3 CIS 25 times 5 CIS 70, the answer is legitimately just 15 CIS 95. All you end up doing is multiplying the radiuses, add the exponent, or add the angles. You're done. Something like this, 8 CIS 100, 5 CIS 40 would just be 5 times 8 is 40 CIS, and then you add the angles, 140 degrees, you're done. The only thing you want to make sure you do is if you ever end up with an angle bigger than 360 or less than 0, you want to use coterminal angles, get it back to within, 0 to 360. If you're dividing, again, you just divide the radiuses, so you end up with a half CIS, and all you do is subtract the angles, 110. You're done. 27 CIS 20 divided by 9 CIS 100. 27 divided by 9 is 3 CIS. Now here we're going to end up with a negative 80 degrees. So again, we don't want to deal with a negative angle. So we just use 360. A negative 80 degrees would be, down here, almost back pointing down there. So, we add 360, and a better answer would be 3 CIS 280. Just getting that back to within 0, 360. That's seriously all that is. So if by chance you are dealing with, multiplication or division of complex numbers in rectangular form, and you want to deal with those, or the end result is you're going to end up dealing with in polar form, it actually is easier, instead of doing the multiplication first and then converting it, it's actually easier to convert. So convert first. So you take that first one. Remember, the way you find your R is the square root of 3 squared plus 4 squared. So that'd be R is going to equal 5 when you do 9 plus 16, square root of that. The first angle, you do the inverse tangent of 4 over 3, right? So that's when you grab your handy calculator, Make sure you're in degree mode. We want our answers in degrees. We do the inverse tangent of 4/3. And we get, inverse tangent of 4/3. We get an answer of 53. Now, we do want to pay attention to quadrant again. You know, this would be in the first quadrant because it'd be right and up, so 53 degrees is the correct answer. We do the same thing with the second one. The second radius would be the square root of the square root of 3 squared, which is 3, plus -1 squared, which is 1, so it would be the square root of 4, or 2. So my second R is 2. And then my second angle, we're doing the inverse tangent of the B, so -1 over square root of 3. We know that simplifies to negative square root of 3 over 3. Tangent, oops, sorry, can't see that. Tangent is square root of 3 over 3 at 30. Again, we want to pay attention to quadrant. That point would be right and down, so we're fourth quadrant, right? So this would actually be like 330, or I could use -30, either one of those I want to. And basically, this is going to boil down to, instead of doing this multiplication problem, what I'm really doing is 5 CIS 53.1 times 2 CIS, and then probably be easier just to use -30 instead, because I know when I add those together I end up positive. Final answer here would just be 10 CIS 23.1. All right. Give a few of these a try. They're actually really, really easy. It's kind of like one of the reasons I like the end of the year. It looks complicated, but it's super, super easy. So again, give a few a try. Send me some pictures. It's been fun, guys.